Hello and welcome to part 5 in my video series on building the Stuart 10V vertical steam engine. In this part I'll be machining the cylinder casting, and before we can get started with actually machining it, there is a lot of rough spots that we're going to have to deal with, sprues and parting lines from the mold that'll need to be cleaned up so that we can mount it solidly for machining operations. So off to the vise for some filing. I mounted the cylinder casting in a 4-jaw chuck to machine the cylinder bore and the first face. That allows me to position it with the center part of the bore exactly centered on the lathe axis for boring. And if I leave it in the same position and then machine the face, I'll be able to assure that those are exactly perpendicular to each other. To get it initially mounted in the lathe chuck, I used the tailstock and the center to get it roughly centered. But because I'm not sure that the core that they used for the casting is exactly centered, to get the center measurement, I'm going to measure off the outside edges where the drain ports are located on the casting. I've noticed looking at the drawing and measuring it that the outer edge of this is roughly circular. And so if I can have all three of those points at the same distance from the lathe axis, then I'll have it reasonably well centered for what we're doing here. So I've gone through and mounted it. I've set up the dial indicator to be roughly 0. And you'll notice if I move it even slightly, I'm getting variations of about plus or minus 4 thousandths. So this is not an exact measurement. It's not like you're trying to precisely position a perfectly round turned object, but it'll get it reasonably close. So if I've got this, I'll call that 0. If I rotate it 90 degrees to this point, move it back and forth, look for the average there. I'll call that about plus 1 thousandth. If I go to the other side and pick about the average, I'm about plus 1 thousandth. If I go back to here, there's actually, if I go to either side, it's plus a little bit. There's a low spot there where it was filed, but that's 0 or 1 thousandths. I'm going to call that close enough for what we're doing here. We've now got it, and I've tightened all of the jaws down. I also like to note that to protect the face here, I've put a small piece of aluminum in there so that I don't damage the face. And at this point, we're ready to bore and machine the surface. I've got to take off a total of 40 thousandths. I'm only going to take off enough at this point to get a good smooth clean surface on it, and then once I've got the rest of the casting machined, I will even this up. I was having trouble measuring the port faces because that surface is quite rough, and so once I have these the two ends flat and parallel to each other, I can do any final cleanup on the milling machine. I want to make sure that the valve ports are exactly centered on the casting, but for now we're just looking to clean up the surface of the casting. With the cylinder bored and the ends faced, I went through and marked out a line across the face that shows the depth of cut that's required to put it the proper distance from the edge of the bore. And then mounted the cylinder in the 4-jaw chuck. You can see I've got aluminum pads to protect the two machine faces. The castings can just be clamped in. And with this in place, I can now go through on the lathe, use a indicator to note the distance from the face along the axis for one edge of the line, and as I sweep this across by bringing the cross slide in, I can make sure that that line is exactly perpendicular to the lathe axis, and therefore I know that when I machine the face, it will end up square. So now we can go through with a carbide lathe tool and machine the valve face of the cylinder, and we'll leave a few thousandths extra for final polishing because that's going to need to be very smooth because that's the operating surface of the valve. With this face of the cylinder casting cleaned up, I was able to get an accurate measurement of the overall thickness from top to bottom, as well as the distance from the outer edge of each of the ports to the face of the casting. I found that I've got 382 thousandths on this side, 381 thousandths here, so they're very close, within a thousandth of an inch. Overall, the casting is at 1.196 inches. I need to get down to 1 1/8, which, when you work the math out, means I've got to take off about 35 thousandths from each side. So to do that, I've got mounted in the milling machine. Was able to clamp it using the flanges on the edge of the casting down to a block, which leaves it flat to machine the two faces. So I'll machine this side, take off 35 thousandths, flip it over, and then machine the other side. The next step on the cylinder casting is to mill steam ports at each end of the casting that will connect the actual cylinder bore to the two steam ports on the valve face. This is a 1/4 inch recess that is essentially centered on the line between the perpendicular to the port face. So we need access to the end of the casting to do this. I'm going to go through and set up the wiggler to go through and make sure that the casting is aligned with the axis of the mill. I can then find the center and move over to an appropriate point where we can make a plunge milling cut to put in the recess. Now that the facing of the casting is lined up with the axis of the mill, I can find the center. The drawings don't actually show the offset from the edge for this milled recess, but the drawings are 1:1 scale, and if I just measure it with a scale, I'm seeing that the edge of the recess is 1/4 of an inch in from the edge. If I add an additional 1/8 of an inch for the radius of the mill, that's 3/8 of an inch back that we need to go. And I can lock that axis of the mill. I can now put in a 1/4 inch milling cutter, and we need to go down 3/32 of an inch. With that port cut in, now I simply need to turn over the casting and repeat the entire process. The exhaust port is listed as optional if you're just building this as a display model, but since I want it to operate, obviously it's going to be important. That's one of the quick ways you can tell, by the way, if you see one of these pictures of them on the internet, if it's an operating model, is it'll have an exhaust port on one side of the casting. If there is no ports coming out on either side, there's no way for the air or steam to get out, it's obviously not a running model. Similarly, you'll see an input port on the side of the valve body that we'll be machining later. But again, this is going to be an operating engine, so I've got to put the exhaust port in. I've mounted the cylinder casting to an angle plate, and it's squared up with the side so that I know that the face is vertical. I'm going to use a piece of steel here to line up the entire casting, the angle plate, with the mill table. It's a quick reference for setting things up. Clamp that down flat, and once again, go back and use the wiggler to find the location for the hole. I know that the casting is that the cylinder at this point is precisely 1 1/8 inches from top to bottom, so I need to go 9/16 to find the center for the exhaust port. 1, 2, 3, 4, 5, 6, 7, 8, 9. And visual check show that that is centered on the exhaust port. And according to the drawing, we need to come in 7/32 from the port face for the center. You may have noticed me counting full rotations. I know that on this mill, 1 full rotation is 1/16 of an inch, so that makes it really easy not to lose track when going fairly long distances. Again, a visual check. That looks to be nicely centered on the boss as a confirmation that we're in the right spot. So the first step will be to center drill it. This is going to be tapped a 1/432 ME, so the closest tap drill size I have is a 7/32. The 1/432 tap is too large to fit in my small tap holder that works with the center, but I was able to put a small piece of aluminum into the chuck to keep it lined up for the start. And again, I'm just wanting to make sure that I keep the tap perpendicular as it gets started so that the threads are straight into the hole. And with the exhaust port drilled and tapped, we can move on to the steam ports that go from the valve face to the 2 ends of the cylinder. Before we can drill the steam ports, we need to figure out what angle these holes need to be at. And from the geometry of the part, we know that from the valve face to the edge of the recess on the end of the cylinder is exactly a 1/4 of an inch. We milled that. We know that it's 0.095 deep. We've measured across the port face and know that it is about 0.347 from the end of the cylinder to the edge of the port face. And if we use the caliper, we can use this extension on the bottom of the caliper to measure the depth of the recess. And if I measure this one, I'm at 0.193. On the other side, it's 0.205. That was just based on the mold. I'll take the lower of those, call that 0.190. And to make this simple, I want to have the center of the hole right at the corner of the recess, because that's an easy spot to reference on the casting. And then I want to have the edge of the hole at the bottom of the recess so that the steam port is coming into the side of that opening. If I then work through the measurements, I have a triangle here with a side of 0.252 and a height of 0.11. If I work that out, that gives me an angle of 23.5 degrees. It's simply taking the arc tangent of the 0.11 divided by 0.252. You can find explanations of that in the machinist's handbook. In order to drill these holes, the part needs to be clamped firmly at the right angle. In the book Building a Vertical Steam Engine, they show using a wooden block with a notch cut out at a 25-degree angle. In this case, I happen to have a tiltable milling vise, so I'm going to put in a pair of parallels to hold it up far enough from the bottom that the hole isn't blocked by the jaws, and then clamp the vise down firmly. That will hold the part very solidly. Now it's just a matter of tilting the vise to the correct angle. To set the vise at the correct angle, I'm going to be using my angle block set. These are basically, they're very similar to parallels, but they are machined at precise angles, ranging 1 degree, 2, 3, 4, 5, 10, 15, 20, 25, and 30. And you can combine them to get any integer angle that you require when doing a machining setup. These were available at a very reasonable price from littlemachineshop.com. I'll put a link to them down below. They've got a lot of nice tooling available, as well as machines for the hobby machinist. And in this case, I'll take the 25-degree angle block. To get a vertical reference, using a 1, 2, 3 block, tilt this at a bit of an angle so you can see how the setup is going to work. I need to space it out a little bit with a parallel. And then if I set the angle block against the vise jaw, I now know that when this is at 25 degrees, this edge will be vertical. I need the parallel to bring that over slightly to match up with the vise, and it's just a matter of tilting this until it aligns. I'm going to do this. This is basically what I'm trying to do. I need to turn it a little better so I can actually see what I'm doing and have my hands in the right place. I'm drilling a vertical hole, so the alignment of the vise to the table doesn't really matter. No matter how I rotate this, it's still at a 25-degree angle. So I'll just take it at this point and clamp it down conveniently so that it doesn't move. With all of the machining operations completed except for drilling the stud holes in the port face, I'm going to go ahead and clean up and polish the ends and the valve face. As with the other parts, I'm going to take the cylinder ends down to about 400 grit paper. I'm going to go down to 1,000 for the port face because I want that very finely polished.